From Launch Complex 39 at the Kennedy Space Center in Florida, this is Shuttle Launch Control at T-minus 3 hours, 39 minutes, 49 seconds and counting. We are now in the finals of the launch of Space Shuttle Columbia on mission STS-83. The countdown is being controlled from Firing Room 1 at the Launch Control Center, and we are on schedule for liftoff at exactly 2 p.m. Eastern Daylight Time this afternoon. This is the 22nd flight for Space Shuttle Columbia and the 83rd mission of the Space Shuttle program since launches began in April 1981, 16 years ago. The primary objective of the STS-83 mission will be to conduct over 2 weeks of experiments inside the Microgravity Science Laboratory Space Lab module, which will include experiments in protein crystal growth, materials processing, combustion experiments, and plant growth experiments. The mission duration for STS-83 is planned as 15 days, 16 hours, 36 minutes, and Columbia will be in a 184 statute mile high orbit. The landing is planned to occur at the Kennedy Space Center on the morning of April 19th at about 7:40 a.m., assuming an on-time launch today. Some of the 7-member flight crew of Columbia were awakened at 1:30 a.m. this morning, while others are still asleep and will be awakened shortly after 9 a.m. They will all meet together in the dining room at about 9:30. Those who have just awakened will be having breakfast, and the others awakened earlier had breakfast at about 3:30 this morning. They may have a snack at that time. Afterward, there will be a weather briefing, and will receive a status on the countdown activity. They will then go to the suit-up room, don their flight suits, and depart at about 10:40 a.m. for the 20-minute ride out to Launch Pad 39A at the edge of the Atlantic Ocean. They will begin boarding Columbia at about 11:15. The launch countdown began on schedule here in Firing Room 1 of the Launch Control Center at the T-minus 43-hour mark at 2 p.m. this past Monday afternoon. Loading of the external tank containing the 1/2 million gallons of liquid hydrogen and liquid oxygen began slightly late this morning at 6:06 a.m. and we are approximately 60% through that activity at this point. Tanking operations were delayed as managers addressed a concern with fuel cell number 2, which was reading a higher than desirable voltage. However, that fuel cell is now stable and is operating properly and is not expected to be a factor in our launch attempt today. The fuel cell is used primarily to generate power during Columbia's 16 days in space. Meanwhile, weather-wise, our forecast is unchanged, with just a 10% chance of not meeting our launch weather criteria this afternoon. At launch time, the temperature will be approximately 77 degrees, relative humidity 52%, and east-southeasterly winds 7 to 12 knots. The visibility will be 7 to 10 miles, and there will be 2 layers of scattered clouds. There's a very slight chance of a shower. And offshore in the solid rocket booster recovery, conditions are also acceptable. The forecast there calling for east-northeasterly winds at 5 to 10 knots, relatively quiet seas, just 2 to 4 feet, and an Atlantic Ocean temperature of 74 degrees. So at this time, all of our countdown activities continue toward a liftoff of Space Shuttle Columbia this afternoon at 2 p.m. Eastern Time. At T-minus 3 hours, 35 minutes, 20 seconds, and counting, this is Shuttle Launch Control. This is shuttle launch control at T-minus 3 hours, 20 minutes and counting. At this point in the countdown, the main propulsion system helium tanks are being filled from their current level of about 2,000 pounds per square inch to their full pressure of about 4,500 psi. And also we're doing the thick resistance test, which is a test of the pyrotechnic initiator controllers responsible for the automatic separation of the solid rocket boosters and from the external tank. And we are now at about the 98% level on liquid hydrogen, and we're behind that on liquid oxygen at about 70%. Liquid oxygen is much heavier, so that takes longer to fill the tank. Liquid hydrogen is the first to be finished, and the liquid oxygen is usually about a half hour or so behind that. Weather-wise, out at the pad at time, we're expecting a temperature of around 77 degrees. However, conditions inland should be somewhat warmer. The cooler temperatures for launch are because Columbia is out at the edge of the Atlantic Ocean, but conditions today favor a much warmer temperature elsewhere. And at this time, we're not working any problems in the countdown. And we are on schedule for a 2 p.m. Eastern Time launch today. At T-minus 3 hours, 17 minutes, 51 seconds and counting, this is shuttle launch control. This is shuttle launch control at T-minus 3 hours, 10 minutes and counting. Loading the external tank with liquid hydrogen is now complete, and we are now topping hydrogen. The oxygen continues to flow into the tank. We're just somewhat over 70% on liquid oxygen. Also, the Mila tracking station at Kennedy Space Center has just aligned its large tracking antennas with the launch pad, and will begin a series of checks. And all our activities are on schedule for a launch at 2 o'clock this afternoon. The payload on STS-83 is the Microgravity Science Laboratory, a pressurized module in Columbia's Payload Bay. We're going to take a tour now of the MS-1 Space Lab.
Hello, my name is John Halsell, and I'm the Payload Operations Engineer for STS-83, the Microgravity Science Laboratory. We're standing inside the orbiter processing facility, and what you see over my shoulder is the Microgravity Science Laboratory inside the orbiter's Payload Bay. The Microgravity Science Laboratory weighs about 10 tons. It's 23 feet long and about 13 feet in diameter. It only takes up about a third of the orbiter's Payload Bay, and the way the astronauts get from the crew module into the Space Lab module is they travel through this long tunnel you see here. So, let's go travel through that and tour inside the module. I'm standing inside the MSL-1 module, the Microgravity Science Laboratory. I'd like to give you a quick tour on the ground before you see this in operation with the astronauts on orbit. To start with, you'll see all over the module little white spots. They're actually Velcro patches for the astronauts to go and stick anything they need to keep it in place. The ceiling you see here is 14 stowage containers where all kinds of things are stowed. Cameras, lights, batteries, VCR tapes, camcorders, anything you could possibly use for this mission. I'd like to show you the experiment on this side of the module, starting with the mid-deck glove box. You can kind of imagine astronauts being able to stick their hands in here. What the mid-deck glove box is a nice closed facility so that anything that's going on inside the glove box won't be able to get out, or, if need be, anything inside the module won't be able to get in. The glove box can have cameras attached to it, and there's a color television monitor here so you can see what's going on. Some of the experiments that are being run inside the mid-deck glove box is a capillary pump loop experiment. What capillary pump loops are heat transport devices. Typical application is to be able to remove heat from electrical components and send that heat to radiators so the energy can be radiated off into space. So far, capillary pump loops have not worked well, and this experiment is trying to understand the fundamental reason why the capillary pumps have been failing. The next experiment you see here in this big open area is called the droplet combustion experiment. It's a Lewis-designed experiment from the Lewis Research Center, and what it does is burn droplets of heptane in various atmospheres. The atmospheres are kept and actually stowed away right now inside the module in small bottles that can be placed here. The bottles can be emptied into the combustion chamber, the test run, and then to evacuate the chamber, the combustion products can be vented off into space to a vacuum vent line out to the back end of the module. The two white boxes you see here are more storage containers. The next experiment takes up a fairly large area. It starts here and goes all the way across. It's called CM1, Combustion Module 1. One of the two experiments being run inside the combustion module is called LSP, which stands for laminar soot processes. Why this is important is if we can understand how soot forms in a flame, that can lead to lower soot formation in combustion processes here on Earth. The second experiment is called softball, and that's looking to see if stationary spherical flame balls can even exist. If they can exist, hopefully the experiment will determine if, in fact, the heat and light radiating away from the flame ball is what stabilizes it. The intent is, or the hope is, that being able to understand this, it can lead to an improved theoretical model of how things burn here on Earth, which should lead to, and could lead to, cleaner burning engines and more fuel-efficient engines. The next area you see here is really not an experiment. These boxes are VCRs to record data on the various experiments. The floor you see here is actually foam pads. The flight floor looks like this, and all the panels on the side lit up for access to the subfloor. And beneath here is more Space Lab support equipment. We've talked about the starboard side of the module, and in general, stuff on this side deals with combustion experiments. I'll go ahead and step over the center aisle hardware, and on the port side is, in general, furnaces. The experiment here is called the Large Isothermal Furnace. There are 27 samples that are going to be melted and re-solidified in this experiment. The furnace can reach temperatures of up to 1600 degrees centigrade and can be rapidly cooled using either helium or argon from gas bottles behind this panel. The next experiment you see here is called, in fact, the Express Rack. It looks different from the rest of this because, in fact, this is a piece of space station hardware. It's being flown to test out procedures and hardware to make sure that when we fly space station, when we build space station, everything will work. An experiment inside the Express Rack, this experiment here is called phase, and what phase is a crystal modeling experiment. There are very tiny micron-sized spheres inside sample containers, and under the right conditions, these spheres will group together to form what appears to be crystals. The two mid-deck lockers you see here in the Express Rack will be in this location for launch, but on orbit, they'll be swapped out, and another experiment called Astro-PGBA will take its place. Astro-PGBA is loaded into the middeck of the orbiter, and the astronauts, once on orbit, will transfer it back into this location. Astro-PGBA is a greenhouse in space. Some of the plants being flown in the greenhouse are a species of sage, which is used for an anti-malarial drug, a plant used in chemotherapy treatment, spinach, and loblolly pine, which is used for wood and paper products. The experiment here is called Tempest, and Tempest is an electromagnetic processing facility. There are 19 metallic samples loaded inside this experiment. What Tempest does is position, melt, and re-solidify the 19 samples using radio waves. The same experiment can be run on Earth, except such a large amount of power is required to overcome gravity, the results aren't as good. In microgravity, much less power is required, and better sample results should be able to be obtained. The experiment can be run in either an ultra-high vacuum or an inert gas atmosphere supplied by argon gas and helium gas bottles behind this panel. The reason this experiment is important is it should improve welding and solderability here on Earth. Inside the lab, there are also 3 different acceleration monitoring instruments. One is here, the microgravity measurement assembly. Another is called QSAM, the quasi-steady acceleration monitoring system. And a third is called SAMS. It's located in the back of the module, and it stands for the Space Acceleration Measurement System. There are sensors scattered throughout the module that will monitor the microgravity environment. Even though you will see the astronauts floating around in space inside the module, there are still small forces and small accelerations due to either a crew member just jiggling a handrail, pumps running, other experiments running, fans running, fluid circulating through loops. They all impart small forces. And scientists need to understand the relationship between these small forces and the results of their experiments. Once activated, these acceleration measurement instruments will continuously monitor the microgravity environment inside MSL-1. The yellow boxes you see along the center of the module are more storage containers. The white box you see in front of me is called HIPAC, and it stands for high-pack television. HIPAC allows us to send up to 6 simultaneous television signals down to Earth versus just one if we didn't have it. And that's important because this way, more scientists can watch their experiments running simultaneously. Now that we've talked about the experiments, we'll talk for a minute about the Spacelab subsystems. Here we have some containers for the lithium hydroxide canisters that are used for air purification inside the module. This is the workbench, and behind it is stowed some pretty normal things, like clocks, tissues, gloves, duct tape, force gauges, bags, and Velcro straps. Across from the workbench is the control center for Spacelab. It contains systems like the fire suppression system, the electrical power distribution system, the air conditioning system controls, and the intercom system. At the back of the module, there's also a fairly familiar item for everybody. This really is a fire extinguisher. In case of a fire, this can be used and placed in a fire hole to suppress anything that starts to burn. And if the astronauts do have some free time, there is also a viewport in the back of the module that the astronauts can look out into. Well, we hope you've enjoyed this more down-to-earth tour of the Microgravity Science Laboratory.
And we're at T-minus 3 hours in holding. We went into the built-in hold about 2 minutes ago. We are now in stable replenish on liquid hydrogen. We continue our fast fill on liquid oxygen, which is going well. The closeout crew has assembled at the area where they mustered just outside the 3-mile limit to the pad, and the final inspection team is also mustered this time, ready for pad entry. And in about another 15 minutes we should have completed our fueling operations, at which time the final inspection team can enter the pad to begin their activities. So at this time, all of our activities continue on schedule for a 2 p.m. launch this afternoon. At T-minus 3 hours and holding, this is Shuttle Launch Control. This is shuttle launch control at T-minus 3 hours and holding. The propulsion console has just advised the shuttle launch director, Jim Harrington, that we still have about 15 minutes remaining in our fast fill of liquid oxygen on board the external tank. Meanwhile, all of the crews are assembled at the roadblock ready for entry. That includes the final inspection team and the closeout crew. And we've also received word that the microwave scanning beam landing system at Banjul is operating well on both strings, primary and backup. That had been somewhat of concern about the backup string, but both of them are up and running, and the mist bliss, as it's known at Banjul, is good. And we continue not to work any problems. Things are going well for our anticipated launch at 2 p.m. Eastern Time this afternoon. Weather continuing to cooperate with just a very slight chance of a shower. Generally, it should be a very good day for a shuttle launch. At T-minus 3 hours and holding, this is shuttle launch control. This is shuttle launch control at T-minus 3 hours and holding. We have 1 hour 40 minutes remaining in this built-in hold. And we are now exactly 5 hours away from the launch of Space Shuttle Columbia on STS-83. We have reached the 98% mark on liquid oxygen fill. So we're now going into the topping mode, and once we reach stable replenish, then we'll send the final inspection team in to begin their operations. The STS-83 astronauts arrived at the Kennedy Space Center last Monday afternoon at about 1:30 p.m. in their T-38 jet trainers, and we'll look now at a brief videotape highlighting their arrival at KSC. It's about a 2-hour flight from Houston to the Cape. There's our commander, Jim Halsell, along with payload commander Janice Voss. Greg Linteris, Roger Crouch, and Susan Still. Susan Still, the second female pilot fly aboard the space shuttle. And the commander had a brief statement.
Hello. Thank you for coming out. It's a great pleasure for us, as you can imagine, to be here at Kennedy Space Center. This is leading up to the moment that we've been training for more than a year. And we're ready. We understand the Columbia is ready. We know the payload is ready. The people at Marshall are ready to support us. So everything is coming together for a Thursday launch, and we're just really looking forward to it. I want to take this opportunity to thank the people here at Kennedy Space Center. We know you've been working tremendously hard, lots of overtime, lots of extra shifts, a lot of weekend work, to Columbia ready to go. I was talking to Mike McCullough just a few days ago, and he's so proud of the people here who have risen to the effort, the level of effort required to make this launch date happen. And it hasn't been easy. It's a great statement about the people who work here that we're going to be able to go on Thursday. As far as we've been told so far, the weather's looking pretty good for a Thursday launch, and we all have our fingers crossed that we'll be able to go on time. And I'd just like to say once again, thank you for being here, and we look forward to putting on a good show for you on Thursday. Thanks a lot.
And of course, at the time the crew arrived, launch was still planned to occur on Thursday. We took an additional 24 hours to assure our mission success by insulating the cooling lines in the payload bay. And after the astronauts left the ramp, they went to the astronaut quarters. Some of the crew went to bed to maintain their staggered sleep cycle, while the others received a status briefing on the countdown and on Columbia and the Microgravity Science Laboratory, as well as taking a look at the weather forecast. On Tuesday, the astronauts all had their final medical examinations, a fit check of their launch and entry suits, and the commander and pilot flew the shuttle training aircraft to hone their landing skills. Yesterday, the crew went out to the launch pad to check on the status of Columbia and of the Microgravity Science Laboratory, and they received a full payload status briefing. And the commander and pilot flew the shuttle training aircraft once again. And the astronauts went out to the pad once again last night to see Columbia after the gantry-like rotating service structure was retracted from around the vehicle. This will be a 16-day mission for Columbia. If we have an on-time launch today at 2 p.m., April 4th, then our landing will be on April 20th, Sunday, April 20th. And the Best estimate on a touchdown time based on an on-time launch would be 7:36 a.m. Eastern Time. And we're awaiting now the liquid oxygen to go into stable replenish. As soon as that occurs, then we'll be sending the final inspection team out to the pad. 1 hour, 34 minutes, 45 seconds remaining in this built-in hold at T-minus 3 hours and holding. This is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 3 hours and holding. We've just gone into stable replenish on liquid oxygen, meaning our tanking is essentially complete, and momentarily we'll be sending the closeout crew and the final inspection team out to the launch pad. And at this time, the astronauts are being awakened in the astronaut quarters. This is the blue team of astronauts. And the blue team being awakened at this time is Michael Gernhardt, Janice Voss, and Roger Crouch. The other crew members have been awake since about 3:30 this morning. And momentarily we should hear that control switching is in effect, meaning no one will be able to touch their consoles during the time that the final inspection team is at the pad. That's a safety precaution to assure that nothing inadvertently occurs which could affect the safety of the final inspection team while they're at the pad. And that should be coming up very shortly. At T-minus 3 hours and holding, this is shuttle launch control. This is shuttle launch control at T-minus 3 hours and holding. The final inspection team has now arrived at the launch pad. And Greg Katnick, in charge of that team, reports they are now on the 255-foot level of the fixed service structure and will begin their inspection of the vehicle and their walk downward toward the mobile launcher platform. At least 6 people make up the closeout crew, or the final inspection team. They will be on pad for about the next 2 hours and will assess the integrity of the thermal insulation on the external tank, look for any ice or frost formations on the tank, measure temperatures on various parts of the vehicle, and assess debris concerns both on the vehicle and on the pad, anything that could be a safety issue. Among the tools used by the final inspection team is a portable infrared scanner to obtain the temperature measurements on the surface of the vehicle, and it can also spot any leaks on the tank or the interfaces between the orbiter and the tank. In particular, though, the team is looking for ice buildup, which on launch could break off and damage the orbiter. The team also takes a last look at the pad to assure that there is no loose debris which could strike the orbiter at launch. The White Room crew has also now arrived on station, and at least 6 people make up the White Room crew, including a pad leader, a support astronaut, a suit technician, a NASA quality control engineer, and 2 Lockheed Martin orbiter mechanical technicians. The support astronaut in the crew compartment this morning to assist the astronauts with their entry and their strapping in is Pan Melroy. The orbiter crew hatch is scheduled to be closed and sealed at approximately 12:30 this afternoon. Meanwhile, the ice team will be continuing to perform their activities. They wear very highly visible day-glow orange protective coveralls that are anti-static and flame resistant, and each member also carries a self-contained emergency breathing unit with about 10 minutes of air. As far as ice is concerned, there must be no observable ice on the top of the external tank, since during launch this could break off and strike the orbiter's windows, and no more than a 1/16 of an inch of ice on the side of the external tank facing the orbit is allowable, since this ice could break off and strike the orbiter's tiles. But frost may be observed, and this is not a problem. Today, however, based on the very warm temperatures, it would be surprising to see any ice or frost on the tank at all. An inspection of the pad on the mobile launcher platform and the space shuttle itself was also made yesterday by the team, and that included a very thorough inspection of the external tank prior to the cryogenic propellants this morning. And the team will return to the pad afterwards for inspections of the pad and to also check the beach for anything unusual, particularly to identify any debris or anything that might have fallen off the shuttle during launch. And then tomorrow there will be a review of the high-speed film and videotapes to determine any possible damage to the shuttle during the launch and the early phase of ascent. Once again, the team can be seen there on the 255-foot level of the fixed service structure. And all of our activities are proceeding on schedule toward a 2 p.m. launch today. Weather also cooperating, no issues there. And we have about 1 hour, 16 minutes, 40 seconds remaining in this built-in hold. At T-minus 3 hours and this is shuttle launch control. This is shuttle launch control at T-minus 3 hours and holding. 1 hour remaining in this built-in hold. We've received word that there are no COLAs today, no collision avoidance quotients. The ice inspection team, final inspection team, now on the 215-foot level of the fixed service structure. And we'll be awaiting the entry of the astronauts into the dining room for breakfast in about another 5 minutes or so. We're not working any technical issues that would affect our launch today, and we're on schedule for a 2 p.m. Eastern Time launch this afternoon. Space Shuttle Columbia on the pad was the first in the shuttle fleet. Arrived at KSC in March of 1979, and the first launch was from Pad A, same pad as we're using today, on April 12, 1981. It deployed the first satellite in the Space Shuttle program on STS-5 and then flew the first Spacelab mission on STS-9. Columbia is named after a small sailing vessel that was based in Boston Harbor in 1792. And another one of Columbia's claims is that it brought back the long-duration exposure facility from space after almost 6 years in space. And this will be the 22nd launch of Space Shuttle Columbia. We're going now into the dining room of the operations and checkout building where the astronaut quarters are located. Should have pictures here momentarily from the dining room where all 7 of our STS-83 crew members will be seated. Still waiting for the dining room video, which we should have momentarily. closeout crew reports that they are ready for the astronauts' arrival. They will be departing for the launch pad at about 10:41 and will begin boarding Columbia at about 11:16. And they have verified that everything in the crew module is ready. They've also checked the air to make sure that there is the proper environment, proper liquid oxygen levels. And the astronauts now are having breakfast. We had some technical problems on bringing that live, so we'll be playing that back to you after a while. We're at T-minus 3 hours and holding. This is Shuttle Launch Control. This is shuttle launch control at T-minus 3 hours and holding. We have 49 minutes remaining in this built-in hold. In just a few moments, the astronauts will receive a briefing, which will include a very thorough look at the emergency landing sites, including our prime emergency site in Africa at Banjul, the Gambia, and the two alternative sites in Spain, should they be necessary. And also they'll receive a briefing on the weather at Edwards and White Sands, as well as the return to launch site here at the Cape, should that be necessary. All of that will be briefed by the Spaceflight Meteorology Group at the Johnson Space Center in Houston. Our local weather for launch, the shuttle weather officer is Ed Perselic, and he reports that our launch weather at this time looks very good, with less than a 10% chance we'll have a weather issues today. There is a slight chance that we'll have some showers develop out over the water and maybe some inland along a sea breeze front. At the pad, the temperature at launch time will be about 77 degrees, relative humidity 52%, and southeasterly winds 7 to 12 knots. Should be somewhat warmer inland. So while there's a slight chance of a shower within 20 miles of pad 39A or the shuttle landing facility, overall our conditions for launch today are excellent springtime weather conditions. At T-minus 3 hours and holding, this is shuttle launch control. This is shuttle launch control at T-minus 3 hours in holding. One of the ICE team members is using the portable infrared scanner to check the external tank for any ice or frost buildup and any lines that might also develop that kind of ice, which could be a concern on launch that could break off and damage the orbiter. ICE team has not reported any ice or frost so far, and it's been a fairly uneventful inspection. Here we see Greg Katnick, who's the leader of the ice inspection or final inspection team, completing his observations from the mobile launcher platform. And all of our countdown activities continue to go smoothly. The final inspection team should be on the pad about another 15 minutes or so. The astronauts are just finishing up their weather briefing and will head for the suit-up room. We have approximately 20 minutes remaining in this 2-hour built-in hold. At T-minus 3 hours in holding, this is shuttle launch control. This is shuttle launch control at T-minus 3 hours in holding. We've just completed our initial checks of the range safety system. And the weather briefing to the astronauts is complete. This briefing was done by the NOAA Spaceflight Meteorology Group located at the Johnson Space Center in Houston, and provides the outlook for an emergency landing should they need one either overseas or here in the United States. Our primary contingency site in Africa is Banjul, and the weather there today is excellent. Skies are clear, just no more than about an eighth of high cloudiness, visibility 9 miles or greater, winds northwesterly 8 to 13 knots. And their microwave scanning beam landing system has been reported is performing well on both strings, primary and backup. It appears that White Sands at Northrop Strip will probably not be available to us today. Their weather is poor. Edwards is somewhat marginal. The main concern there would appear to be a forecast for higher winds this afternoon, so we'll just have to watch and see how the winds perform as far as using Edwards for an abort once around. And all of the countdown activities proceeding smoothly. Local weather continues to cooperate, watching for maybe some showers developing offshore over the Atlantic, and maybe some after lunch inland along the sea breeze front as that develops sometime afternoon. 15 minutes now remaining in this built-in hold at T-minus 3 hours, and holding. This is shuttle launch control.